Hello students, welcome to this another session. Today also I'm started solving it around midnight and it's 12:40. I'm doing the analysis after solving the paper. So in the test 68, 3 questions I have regarded tough, 2 because of the mathematics and 3 because of slightly, let's say it might be tougher for you. 21 were medium, 21 were easy. One question 29 I feel is not the right way to ask a question. Otherwise the paper is normally doable. There are many questions which you can just tick and move ahead, so it is not going to be that tough. So here score should be there. So for any student who is above average in physics, it should be 135 or 140 plus, and for very good students it should be 165 plus category paper, or 160 plus. You can say 165 plus might be asking too much from you, so let's say it should be 160 plus paper for very good students in the physics section. So let's see what is in the paper. So let's begin. First question: an electron collides with a hydrogen atom in its ground state and excites it to third level. Okay, n equal to 1 2 3. The energy given to hydrogen atom in this inelastic collision is, so the energy given to hydrogen atom basically is the energy required for its excitation, that is basically E3 minus E1, and you remember E3 is minus 1.5 eV, E1 is minus 13.6 eV, so it is approximately 12.1 eV. So go for option B. So it's an easy one for you. Next, at what speed should the electron revolve around the nucleus of a hydrogen atom in order that it may not be pulled into the nucleus by electrostatic attraction? Take the radius of orbit of the electron as this, the mass of the electron as this, and charge as this. So simply here it is simply talking of that classical model where you will assume mv square by r. Required force is given by k q1 q2, which is hydrogen atom, so it would be k e square by r square. So what you require the radius to be 0.5. you need the speed, so speed would be what you will have, it is k e square upon m into r under root. So if I do this and take e common, this is k is 9 in 10 to the power 9, m is given as 9.1 into 10 to the power minus 31, and it is 1.6 into, this is radius is 0.5 angstrom, so I should write it as 5 into 10 to the power minus 11. E you know is 1.6 into 10 to the power minus 19. If I take the powers 31 and 11, 42 and 9, 51, so I take 10 to the power 25 out and 10 remains, so it would be 90 upon, this would be 5, and this is 45.5 I can write. Okay, so it would be approximately root 2 into 1.6, that is 1.6 into 1.4, so it would be 2.25, nothing in that. You have to just check the power, and power is 10 to the power 6, so go for option C. So I should write it completely 2.25 into 10 to the power 6 meter per second, because those students who would be receiving PDF should get the answer. So I am writing it. Next, 3 identical spheres of mass m each are placed at the corner of an equilateral triangle of side 2 meters. Okay, taking one of the corner as origin, the position vector of the CM is okay. So here the coordinate is 0, 0. Here you can write 2, 0, and here because of the symmetry x coordinate would be 1 and y coordinate would be this 2 sine 60. 2 sine 60 will give you root 3 meters. So you got the coordinates. Now what is xcm? Just apply m1 x1. So first m into 0, second m into 1, third one is m into 2 divided by total mass, which is 3m. So above we will get 3m by 3m, that is 1 meter. That is what you could directly say from symmetry also. So x coordinate is 1 meter, and from here only you can go for option D, but let me calculate YCM also. YCM would be m into 0 plus m into 1 plus m into again into root 3 plus m into 0 divided by 3m. So it comes out as 1 by root 3. So it is 1 by root 3. So I cap plus j cap by root 3. So go for option D. It's not a tough one. You could do that one. Next one. Ball having velocity v towards the right and having angular velocity clockwise, okay, approaches the wall. It collides elastically and moves towards the left. Ground and wall are frictionless. Select the correct statement about the angular velocity. So in this collision the force will act like this. The normal whose torque will be 0, so omega will remain the same. So it is clockwise and it will remain the clockwise for sure. This is a question you should easily do. This is a very generalized one. Next, sphere is suspended by a thread of length L. The minimum horizontal velocity which has to be imparted for it to reach the height of suspension is, so it is suspended by a thread of length L. Because it is a thread, it can get loosened up So what you need, the minimum horizontal velocity which has to be imparted to the sphere for it to reach the height of suspension. So here you need not get the complete vertical looping, you just require it to reach this height. That means go like this, turn by 90 degree. So here you know tension can never become 0, so just at limiting case, let's say VB is 0 and I have this U minimum. So applying, we know because tension is always perpendicular to velocity, so applying energy conservation, the height gain is L. So gain in potential energy mgl is loss in energy, that is half mu minimum square. So that U minimum would be equal to root of 2gl. So you can go for option B, basic question of energy conservation in vertical looping. Next, flywheel is at rest is to reach an angular velocity of 24 radian in 8 seconds with constant angular acceleration. The total angle turned, because it is constant angular acceleration, I can directly use delta theta would be equals to omega initial plus omega final by 2 into delta t. You can directly apply, no need for calculating alpha. So it starts from rest, so 0 plus 24 upon 2 into 8. So this is 12 into 8. This comes out to be 96 radian. So the option D would be the appropriate one for here. Next one. Variation of resistance of the conductor with temperature is as shown. The temperature coefficient of the conductor is. So it is given the slope and this is R0. What we know, R is equal to R0 1 plus alpha delta T. Okay. So if I write it, it would be R is R0 plus alpha R0 delta T. So if I compare it, this is Y equal to C plus mx thing. So this m is alpha R0. So m is equal to alpha times R0. So what you need, alpha would be m by R0. So it's not a tough one. It's simply checking you whether you know the formula and how to use it. Now go for the next one. The figure shows a network in which the cell is ideal and it has an EMFE. Okay. The potential difference across the resistance 2R is. So again 2R means between these 2 points. Let me mark them. Let's say B and let's say M and A I write. Let's say M and B I write, and I write it as A. Now across AB is E. Now what is 4R and 2R in this is in parallel, so it come out as 4 into 2 upon 4 plus 2. So if you do this, this comes out as 4R by 3. Okay. So this is 4R by 3 and this is R. So I can directly say if this is V1 and this is V2, I know V1 plus V2 is V, E, and V1 by V2 is, you take the ratio of the resistances, which is R upon 4R by 3. So that is 3 by 4. So you can directly make out, you could have directly written also, but I have just to explain you, this would be 4 upon 4 plus 3 times C. So it is 4E by 7. Go for option B. So it's an easy one, not that tough. Next one. The magnetic flux near the axis and inside the air core solenoid of length 60 cm carrying current I is this. Okay. Its magnetic moment will be. Now magnetic flux near the axis and inside the air core is this. So what we can have magnetic moment, you know, magnetic moment you directly write as NIA. So first of all, field inside you write it as mu naught. Small ni, yeah, mu naught ni by L, whatever you write, you can write it like that, mu naught ni by L. This is B. So what is the flux? Flux would be mu naught ni by L into A. A is the area of cross section that you write. Now what is magnetic moment? Magnetic moment is NIA. From there you can write it as phi L upon mu naught. What is phi? 1.57 into 10 to the power 6. What is L? L is 60, that is 0.6. What is mu naught? 4 pi into 10 to the power minus 7. So this becomes 10 to the power 13. 1.57 I can write it as pi by 2 because 3.14 by 2 into 0.6 upon 4 pi. So this pi goes. So this is 0.6 by 8 into 10 to the power 13. So let it do it 60 by 8. So 60 by 8 would be what we can write 30 by 4. 30 by 4 is, let's say, 7.5 into 10 to the power 11 I can write. So 7.5 into 10 to the power 11, that is what I can write here. So none of the option is matching, and if I am seeing their solution, they have taken this flux to be 10 to the power minus 6. Okay, if I have taken it 10 to the power minus 6, then it would be 0.75 because 10 to the power 12 would have been the change. So for me it's bonus, and if they have made that correction, it would have been option C. So right now it's bonus. Next, question number 10. Power dissipated in an LCR series circuit connected to an AC source of EMF is. Now LCR circuit power, you know, power is simply VRMS, IRMS, cos phi. That is what you write. And what is IRMS? You know that is VRMS by Z, so you write it as VRMS square by Z, and cos phi is R by Z. So simply this is cos phi is R by Z, so what it comes out? It comes out as VRMS R by Z square. So going by the option R by Z square is R square plus XC minus XL whole square, so option D matches with it. That is the option we can go for. Next. An electrical force between two charges is 200 Newton, and we increase 10% of charge on one of the charges and decreases 10% on the other. Then what would be the force? So what we have, K Q1 Q2 by some R square was 200. Now let's say Q1 is increased by 10%, so it becomes 1.1 times Q1. It is decreased, so it becomes 0.9 Q2 by R square, and you need to find out this. So 1.1 into 0.9, 11 nines are 99, that would be 0.99 times this value, which is 200. So 200 into 0.9, 99 2s are 198 Newton. So overall it has decreased by 2 Newton. So I'll go for option C here. Next. The ratio of electric field intensity at P and Q in the shown arrangement. Okay, let me see what it is. This seems to be a point charge. This is a shell. This is a shell. Okay. So electric field intensity at P and Q. So at P and at where we are, and Q is okay. Q is a point. Okay, so charge is, it is not a point charge. I was wrong in interpreting. There are two charges only. So first of all, because it is spherical symmetry, I can directly use the Gauss law. For here, what I can say, Q enclosed is Q. So E at P is KQ by what we have, this distance is R square, and E at Q again spherical symmetry, the enclosed charge would be 4Q. So K into 4Q upon 2R whole square, so again it would be KQ by R square. So the ratio is 1:1. The field intensities will be same at both the points, so go for option C. Next one. Kepler's third law states that the square of the period of a revolution of a planet around the sun is proportional to third power of the average distance. Okay, T square is KR cube. If masses of the sun and the planet are m and m, and as per Newton's law, this is the relation between G and K described as. So you remember this, no need to do this. You know T square is 4 pi square upon G, mass of the sun, which is capital M, which is given, into R cube or small r cube, whatever you write. This is the relation that you already know. So what we have, K is 4 pi square upon Gm. So the Gmk is 4 pi square. You directly remember this. If you want, you can derive. There's no point in it. You all remember this. This is how you derive the result. Next. The acceleration due to gravity on the surface of planet is 1/4 on the value of Earth. When a brass ball is brought to this planet, its mass doesn't change, only weight will change, and weight will become 1/4. Mass won't become 1/4. You should remember this. One is intrinsic, one is extrinsic. So remember that. If the emission rate of a black body at 0 degrees R, then emission at 273 is 0 degree, you know, in Kelvin is 273, and this is in Kelvin is what you can say 546, double of that. So temperature is doubled, so you know that H is proportional to T to the power 4. The temperature is doubled, so it is 2 to the power 4, 16 times it will become. So then now the rate would be 16 times R. This is an easy application of Stephen Boltzmann law. Next one. A cyclic process is depicted in the pressure temperature diagram. Which of the following is same on PV diagram? So again the curve transformation. First of all, A to B, it's looking like passing through origin to me. Yes, so volume is constant for A to B, so this is rejected, this is selected, this is okay, this is rejected, and we are left with B and D. Now where's the difference? The difference in C to A. So just see C to A. C to A is a constant temperature, so it would be an hyperbola on that curve, so it cannot be D, it can only be P. So looking at by these, you can make out this is option B is the appropriate one here. Next one. An ideal gas is taken through a cyclic thermodynamic process. Okay, 4 steps. Q1 given, Q2 given, Q3 given, Q4 given. Very good. Corresponding works are given. It's an easy one. For a cyclic process, you know Q net barabar W net. So Q1 plus Q2 plus Q3 plus Q4 would be equal to W1 plus W2 plus W3 plus W4. So what we are required, W4, that would be the summation of all minus summation of that all. So just add them up. So simple calculation. So if I am add them up, so these two are positive, so let's say first add them. This would be 5, this would be 10, So 10 and 6 16 goes 1, and that would be 9605 minus this would be 5 and 0 5, 8 and 8 16, then you have 9 and 6 15, then you have 6 and 2 8. So this is the QNet, and W1 plus W2, what we have 22 and 1100 minus 825, that is you can roughly make out this is 275 roughly. Yeah, you can do it and mentally. So now what we have 5 and 5 0, 10 and 6 4, 5 and 5 0, 1040 minus 275. If I am doing right, this is 5, this would be 13 and 7 6, and this would be 9 and 2 7, 765 joule. I am getting the answer. I am assuming I am right. Yes, I am right. Next, ions of different momentum. Okay, it is ions of different momentum P having the same charge enter normally a uniform field. The radius of the orbit of an ion is, what you know, in a magnetic field perpendicular entry R is mv by qb. So ions of different momentum, that is P by QB. Q is same, P is different, so R is proportional to P, that is for sure. So again, that's an easy one for you. This is A. Next, a galvanometer of resistance 50 ohm giving full scale deflection for a current of 10 milliampere is to be changed into a voltmeter of 100 volt. So first of all, what is Vg? Vg is Ig into G, 10 milliampere into 50 ohms. So that comes out as 500 millivolt for us. So that 500 millivolt you can write as 0.5 volt is to be converted into 100 volt. That means that factor n is 200 times the range has to be increased. Now the R of series required is equal to G into n minus 1. You already remember. So G is 50, n minus 1 is 199. So you have 0, 5 9s are 45, 5 9s are 45, 9 4 9, 9950. That is the answer that I am getting. So it should be option A. Let me check. Yes, it is 9950 given by NTA. So it's the right one. Next one. Nickel shows the ferromagnetic property at room temperature. Okay, if the temperature is increased beyond Curie temperature ke beyond, you know, beyond Curie, a ferro starts behaving as a paramagnet. So option D will be the answer. Next one. The position coordinates of a particle in xy as a function of time is given like this. The speed at 10 seconds is. So let's say calculate differently. First of all, Vx is dx by dt. It is 4t plus 6. Vy is dy by dt, which is 2t plus 2. So at t equals to 10 second, what we have, V will become Vx I cap, V will become 40 plus 6, 46 I cap, this will become 22 j cap. So 46 I plus 22 j, so magnitude of V would be 46 square plus 22 square. So 46 square plus 22 square definitely greater than 31. Now how to do this? 46 square, let's say 46 into 46, what do you have? 6 6 are 36, 6 4 are 24, 24 48, 48 and 351, 4 4 are 16 and 5 2 1 1 1 6, 2 1 6 plus 22 square, 22 into 22, 22 2s are 44, 22 2s are 44 and 4 484. So what you are left with, 6 and 4 10, 8 and 2 10, this is 6 and this is 2, 2600. Now you can make it out. What you know, the square of 50 is 2500, so it would be closer to 51 units for sure. So this is the answer now. Next one. 3 balls are projected from the top of a building with equal speed but at different angle. Balls strike the ground with velocities v1, v2, v3 respectively. It should be speed as per the question. You can see now at this point k is same, and as they go the height descended will be same. Loss in potential energy is going to be same. K initial is same, so K final is going to be same. So final speeds will also be same because all have gained the equal amount of kinetic energy. Initial was same, so final will be same. So it's a very common question you all have done. A man of 50 kg is standing at one end of a boat of length 25 meter and mass 200 kg. Okay, if he starts running and reaches the other end, he has a speed 2 with respect to the boat. The final speed of the boat is, so you just remember, let's say boat will go backward with a speed, let's say VB. Its speed is 2 with respect to boat. That means with respect to ground it would be going with the speed 2 minus VB. And you know, because no external force acts, its momentum along right should be equal to the momentum of boat along left. So boat's mass is 200 kg into left, which is let's say VB, and this one would be 50 into 2 minus VB. I can write. Let me rub it. Okay, let me draw it again. It is VB and this is 50. Okay, so 200 VB, 50, this is 4. So 4 VB is equal to 2 minus VB. So VB comes out as 2 by 5, that is 0.4 meter per second. Okay, 2 by 5 is the option. So option A I'll go for. Next one. piece of wire is bent in the shape of a parabola. Y is kx square. Okay, y-axis vertical with a bead of mass m on it. Bead can slide on the wire without friction if it stays at the lowest point of the parabola when the wire is at rest. Y is now accelerated parallel to x-axis with a constant acceleration a. The distance of the new equilibrium position of the bead where the bead can stay at rest with respect to the wire from the y-axis is. So first of all, let's say this wire is like this. This is x-axis, this is y-axis. So if I draw y equal to kx square, it would be something like this. Now it is given accelerated parallel to x-axis with acceleration a. So now it will slide to this position somewhere here. So what will be now? This would be normal to the wire. This would be the pseudo force in the frame of wire MA, and this would be mg. Now it can stay at rest here. Okay, so it is stay at rest with respect to wire. So first of all, at this point I need to draw this tangent. I need to get this tangent drawn, and after this tangent, let's say this tangent makes an angle theta here, theta with this axis. So this is theta, so I can say this will also be theta, and this angle mg1 will be 90 minus theta. So what I can directly say, ma cos theta would be equal to mg cos of 90 minus theta. That means ma cos theta would be equal to mg sin theta. So tan theta, if I write tan theta, it comes out as a by g. And if I take the slope, actually it should be tan of 180 minus theta. I have taken the magnitude thing. So for this curve y equal to kx square, slope of tangent you know is dy by dx. That is equal to 2kx. That is equal to tan theta basically. So here it would be minus tan theta, I know, because of that negative sign. So I have taken the magnitude only. So I'll take this magnitude only. So no need to write this. I can say this was tan theta. Sorry, this is tan of, as per my thing, this is 180 minus theta. So what I can have, I can just equate the magnitude. No point in doing that. We know the value would be negative. So simply a by g is going to be equal to 2kx. So x is going to be equal to a upon 2kg. So a upon 2kg we have as an option. Yes, we seems to have an option. Yes, option B. So this one, actually it should be minus if it is right, and if it would be left it would be positive. So it is not given it is right or left. Parallel to x-axis only was given, so I can go for that. If minus option was there, it could also be incorrect. Next, so this one is fine here. The curve of binding energy per nucleon is a function of atomic mass number as a sharp peak for the helium. This implies we know all the alpha white alpha decay happens because the alpha particle has very high binding energy as compared to its immediate neighbor. That means it is very, very stable. So go for option B. Next one. Select the true statement. Okay, true statement. Nuclear force is strong, short range, charge independent, attractive, long range, strong, charge dependent, and short range, attractive, long range, charge dependent, attractive. You know it is not long range for short, it is short range. Now it is attractive force or not, there's a doubt. You know, you remember that figure, if they came very closer, it instead of attractive it becomes repulsive. So I'll go for option A instead of option C. And also it is charge independent. You know the force between proton is same as proton, neutron same as neutron. So therefore you can remember this particular thing. Okay, so this is the thing you need to remember. Okay, so it is short range and strong short range and charge independent force. Okay, attractive repulsive is somewhat a difficult thing. Generally we say it is attractive only, but I am going by this thing. This is charge dependent, this is charge independent, so it is good enough for me to make out. Next one. For a particle executing SHM, the displacement x is given by this. Identify the graph which represents the variation of potential energy as a function of time and displacement x. Okay, so the displacement x is given by a cos omega t. That means at t equal to 0 it is at x equal to plus a, so potential energy is maximum. So it is the first graph is for potential energy, that is I can say. And you remember potential energy in terms of x, you know potential energy is equal to half kx square. So the graph would be like this for potential energy. It would be like this. Let me draw it clearly. Let me draw it again. It would be potential energy. So potential energy curve is going to be which one? Third one. So it is first and third. That is going to be the answer. That's an easy one for you. You can easily make it out. Next. Such questions have been asked before also actually. Next. Pendulum suspended from the ceiling of a train has a period t when the train was at rest. When it is accelerating with a uniform acceleration, the period of oscillation will, what will happen to the period of oscillation when it is accelerating with a uniform acceleration? So what happens now? Let's say train is now going with uniform acceleration a. So now what happens in this particular case, the equilibrium position also gets shifted, and you draw this force ma and you draw this force mg, and in this particular case you write that g effective basically becomes under root g square plus a square. So g effective increases, time period you say is 1 upon g effective inverse, because it increases, time period is going to decrease. So we'll go for option B for this particular case. Next, two photons of same frequencies move in the same medium. They must have, because frequency is same, their energy will be same and their momentum will be same, and because medium is so what will have same linear momentum and same wavelength. Okay, same linear momentum and same speed is same, definitely same energies and same linear momentum, none of the above. So here almost all things are looking same, but I'm picking this term. Same linear momentum means it's a vector quantity. You cannot say both are moving in the same direction. So therefore we cannot say same linear momentum. Same magnitude of linear momentum we can say, but not the same linear momentum. So as per this, none of these would be the option, otherwise all three will be the same. Okay, next one. So slightly a tricky one. I don't think that's a nice way to ask question. If the kinetic energy of a moving particle is E, then the de Broglie wavelength is. Okay, kinetic energy is E, lambda is h by p, mv is root 2 mk, so h by root 2 me. So this is perhaps one of the easiest one you will encounter. Next one, if a capillary, in a capillary having a cross sectional area A, the water rises to height h. Okay, if the area becomes a by 9, that means the radius becomes r by 3, and we know that h into that radius thing remains constant, so r becomes 1 by 3, so h becomes 3 times for sure. So it would be 3h. You remember this particular thing, so go for it. So the option B is the right one for this particular example. Next, two bodies are in equilibrium when suspended in water from the arms of a balance. The mass of one body is 36 and the density is 9. The mass of the other is 48 and density in gram per centimeter cube is. So I'm assuming the distance will be same, so their masses must be the same. The effective, that effective force you write as mg1 minus rho f by rho b. That must be same for both. So what we have, this is 36 gram, that g will be cancelled out, so I'm just writing 36. 1 minus density 9 upon rho of fluid, so sorry, rho of fluid is 1, so it is 1 by 9. It is fluid in water, yes, 1 by 9 I am writing, and here it is 48. 1 minus 1 upon rho of the other body, rho 2 I can write. This is 3, this is 4, what I get, 3 minus 1 by 3 is equal to 4 minus 4 by 4 rho 2. So if I take that 4 minus 3, that would be 1 plus 1 by 3, and this would be 4 by rho 2. So 4 by rho 2 comes out as 4 by 3, so rho 2 comes out as 3 for sure. So option C would be the answer here. Next one, ray of light incident on the surface of glass slab at an angle 45. Lateral shift produced per unit thickness is 1 by root 2, then the angle of refraction is. So for the lateral shift, if you remember the formula, that lateral shift delta x or whatever you write, that was t sine of I minus r upon cos r, if you remember that thing. So here delta x by t is asked, that is 1 by root 3 given, that would be equal to sine of I minus r, that is 45 minus r upon cos of r. Okay, so now you have to solve it. Okay, let's try it. So cos of r is root 3 times sine of 45 minus r. Now so what is sine of a minus sine of b? So if I write it, it would not that be easy. It would be sine 45 cos of r minus cos 45 sine of r. Sine a cos b minus cos a sine b. This is like that. So what we get now, sine 45 is what we have, 1 by root 2. So I take it 1, I divide it by cos r, what I get, root 3. Sine 45 is 1 by root 2, that comes out as 1 minus 1 by root 2, and this becomes 10r. So what you get now, 1 by root 3 is equal to 1 by root 2 minus 1 by root 2, 10r. So take it here, 1 by root 2 10r, take this side, this would be 1 by root 2 minus 1 by root 3. So 10r would be 1 minus root 2 by root 3, so root of 2 by 3. So we are going with option B. So slightly a use of trigonometry that you are not very comfortable with, I know most of the medical students, but this is how the question is. Next, monochromatic light is refracted from air into a glass. Okay, the ratio of the wavelength of the, so what we know, whenever medium changes, frequency remains same, so the ratio of lambda 1 by lambda 2 is same as speed 1 by speed 2. So lambda air to lambda glass would be equal to v in air to v in glass, and you know air speed is more v, that is equal to mu basically, so lambda air by lambda glass, so that ratio air into a glass, so ratio if I air to glass if I take, it would be mu is to 1 for the sure. Next one, ice skater spins at this angular speed, arms extended. Now when she fold is 75% of the arms extended, that means I reduces some angular momentum conservation because no external force acts, I omega is constant, it becomes 3/4, so it becomes 4 by 3, so it becomes 4 by 3, that means it becomes 4 pi radian per second. As she folds her hands, her omega increases, as she spreads it, it decreases. Next, the wheels on the old time bicycle shown in diagram have radii of 60 and 10 centimeter. Okay, interesting cycle. If the larger wheel is rotating at 12 radian per second, what is the angular speed of the smaller wheel? So again you will take it as a belt example, the linear speeds must be the same, so what I can write, omega big into r big is omega small, r of small for sure. So omega big is 12, radius is 60, small one is 10, so what is the omega of the smaller one? So omega of the smaller one will be 12 into 6, that is 72 radian per second. Smaller one have to turn faster. Okay, next one. So diagram was good, but the question is so quite easy if you understand it. Next, the input signal to a CE amplifier, common emitter amplifier having a voltage gain 150 is this output signal. So because it is 150, 2 into 150 will become 300. We are left with two choices, and we know here you had that minus sign which shows a pi phase change. So it is pi by 3, it cannot be pi by 3, it would be pi plus pi by 3, that is 4 pi by 3. That is a question asked many times on this concept. Now the input of A and B for the given Boolean expression is, okay, what is the, for what it would be 1, okay, we need to check. So let's try it 0. So 0 plus 0 bar, so 0 plus 0 is 0, so 0 bar will become 1 dot 0 dot 0, that would be 0, that bar would be 1, so 1 dot 1, that is going to be 1. So the first option is giving me 1, so I'll go for A. So that is your luck that the first option is matching. You can try with other also. The liquids A and B are at 30 and 20 respectively. When mixed in equal masses, temperature comes out as 26. So specific heat is in the ratio m is to n. Then what happens? So what we say, the change in A is of 4 degree. That means mass of A m, let's say S of A into change is 4. That is the heat lost. That would be heat gain. Heat gain would be m into SB into 6. So the SA by SB, that comes out as 6 by 4. So minimum value is 3 by 2. So 3 plus 2 would be 5. So they have not given 10 as an option. Otherwise you might do some mistake, but it's okay. Next one. The set of physical quantities among the following which is dimensionally different. Velocity, 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 all velocity will be same, so no issue. Potential, work, kinetic, all are same. Disintegration constant, it is 1 upon time. Frequency 1 upon time, angular velocity 1 upon time, dimensionally it is same, so definitely we'll go for the last one. Dipole moment, electric flux, electric field, you know flux and field are definitely different because flux is field into area, so go for D. So it's an easy one, though you have to read all 4 options. Next, in YDSE the spacing between the slit is D and wavelength is 6000. If the angular width of a fringe formed on a distant screen is 1 degree, calculate D. So we know that angular fringe width, that you write it as, that is lambda by D. So lambda by D is 1 degree, so 6000 angstrom into 10 to the power minus 10 upon D is 1 degree converted into radian. Just remember, you don't write in degrees, so we know pi radian is 180 degree, so it would be pi by 180 something in radian now. So this is the only thing that you could do wrong here. So it is 6 into 10 to the power minus 7 into 180 divided by pi. So again this would be 18 6 are what you have, 108 into 10 to the power minus 6 by pi. So what we have now, so 3.14, or better I should write it at 22 by 7 as it come. Let me try. 108, it is 22 by 7. So 22, if I do 22 22 5s is 110, so it would be approx 5, so 7 5s are 35, so 0.35 into 10 to the power minus 6, so it would be definitely 0.03 mm. That would be the closest one you can go for. That is the way you will write it. Next one. In again YDSE, the source is white light. Okay, one slit is covered with a red filter and other with a blue filter. There shall be, because one is red filter, one is blue filter, frequencies are different, so we have non-coherent sources, and because of non-coherent sources there will be no interference for sure. So whenever this filter types question come, you must have done in your practice, if you have done sufficient practice, because now you have lights of different frequencies, and without a coherent source you can't observe a sustainable interference pattern. Next, wave pulse is described by this equation. Okay, another wave pulse in the string is by this equation. The value of y1, y2, x in t is in second. Which of the following statement is correct? Now the first one, it is x minus t by v form. That means this one is going into positive x. This is x plus t form, so this is going into minus x. So y1 travels along plus x and y2 travels along minus x. So the first option is wrong. Both travels along plus, ye be wrong. Now at x equal to 1 meter, y1 and y2 always cancel, and t equal to 1 second, they always cancel. So let's try for x equal to 1. So at x equal to 1, y1 would be 5 upon what we will get, 3 minus 4t whole square plus 2, and y2 becomes minus 5 upon, this would be 3 plus 4t minus 6 whole square plus 2. Okay, so what it becomes, minus 5, and if I do this, this becomes 4t minus 3 whole square plus 2. So 3 minus 4t square or 4t minus 3 whole square, it is one and the same thing, so definitely these are opposite to each other. So y1 plus y2 will be 0 always at x equal to 1. So we'll go for option C, no need to check for D now. Next one, a simple wave motion is described by this amplitude as, so you know, you have done this a sin theta plus b cos theta, so the amplitude you know is under root a square plus b square, 5 square plus 5 root 3 whole square. That is what you can write. So it's simply 5 common, it would be a root of 4, that is 10 units. So amplitude is 10 units. This question you have done many times. Just remember for SHM, whenever you have a sin omega t plus b cos omega t, using rules of trigonometry, you say it can be written as root a square plus b square into 10 of omega, into sine of omega t plus 5. Phi also depends on a on b, so this is the amplitude root a square plus b square. That is what I have used here. Now the last one of the paper, it's 12:35 in my watch. A body of mass 3 kg is moving under the action of a force such that displacement is s equal to t square by 3, where t the time is in second. The work done by the force in 2 seconds is, okay, so s is 1 by 3t square, so I can directly go for change in kinetic energy for w net is delta k. That would be the best method, I suppose. So what I will do, I'll differentiate this. So I'll differentiate this ds by dt, that comes out as 2t by 3. So what we have, the velocity at t equal to 0 comes out as 0, velocity at t equal to 2 second comes out as 4 by 3. So w net is half m v final square minus v initial square, so half into 3, 4 by 3 whole square, because initial one is 0. So 4 by 3 whole square, if you will do, what we'll have, half into 3 into 16 by 9. So this is 8, this is 3, so 8 by 3 joules. Go for option A for sure. So this was today's paper. Keep watching, keep sharing the channel, keep pouring in your comments, keep pointing out my mistake if I have done any one like you have done. So do that, I'll acknowledge it, because solving them real time, sometimes it happens that some mistakes might be done. Okay, please, thank you for watching.